Hey guys, welcome back to the channel. This is part 2 of the generator install series. This is in Clark, New Jersey. I'm up on the ladder here, and what I'm doing is I'm protecting that orange cable for the generator wire, and it goes across the attic to the other side. But here on the outside, what I'm doing is I'm using PVC to physically protect it. Now that cable is actually rated for in-ground use, direct burial, we'll say. But I think it looks kind of obnoxious down the side of somebody's house without some conduit. So the last time I did this, I used this type of cable. I used 1.25 inch conduit, and it was hard. It was a difficult install to get that cable through 1.25 inch PVC. But with this 2-inch PVC, it was a breeze. Now I know if you're in the trades, especially if you're an electrician, and you're watching this, you know 2-inch PVC is just costs a fortune these days. Unbelievable. This whole job, I couldn't believe how much it cost me to put in. But we got it done. And you'll see by the end of the video here, we'll start the generator up. So I'm attaching a 2-inch male adapter there to the automatic transfer switch, and it'll receive that orange cable right in the front of the shot there. But we're going to put it in PVC to protect the wire. What I'm using here is, I believe we call this a PVC awl. So there's different components to this particular PVC fitting. And this is exactly what I needed to be able to make this turn right here. Just like on the left side of the transfer switch, I couldn't come directly in with the piece of conduit, even with a 90 degrees. So I had to use, on the other side, 2 LBs to get into there. Here, I just had to use the one coming down, and it all worked out really well. So I like to get a nice dry fit first, make sure everything fits before I glue and make everything permanent. So I'll do a dry fit. So there's that awl. I forget what we call that PVC. If you know what that PVC fitting is called, leave it down in the comments. It's new to me, and I don't. This particular job is the first time I ever used them with 2-inch. I'm used to the 1/2 inch and the 3/4 inch EMTs, but I didn't even realize that they made these in PVC. So this is the first time I'm actually using it. So, and what I'll do here is I'll slip this 2-inch PVC up into the bell bottom of the first piece of PVC that I laid to the house. And then I'm also going to install a 2-inch expansion coupling. So right there, I'm just getting a rough measurement right here, and I'll cut this pipe, and I'll put the expansion coupling in, and that'll allow me to push the cable through the conduit opening, the PVC awl, to make the final attachment of the conduit into the PVC fitting. So there you go. Now there you can see how we made that turn right there. And so, being that this PVC is actually 2 inches, it's a lot easier to put that Generac cable through the PVC assembly. This is the easy part, getting it through, but when it gets tight and you're pulling from the other side, it went, and just a little bit of elbow grease, I think they call it. We've all been working in the heat, and I've been dying out there. I think on this particular day, I'm in the shade here. That's just by luck. Yeah, I've gone through a lot of t-shirts this summer for sure. Anyhow, that's the Generac cable. So it's got number 2 aluminum. It's got 3 conductors that size. It's got the 2 hots, and the neutral are number 2 aluminum, and the equipment grounding conductor is probably a number 4 aluminum. And it comes with all the transfer wiring, N1, N2, the battery charger T1, and of course the 0 and 94 and 23, or 194 and 23. It's nice to have this thing all in the same jacket. And I'll put some tie wraps around the wire so it's nice and tidy inside the transfer switch. That's something I probably didn't do when I first started doing these generators. But I've done a lot of them now, and fairly confident in each of the installs that we do. The signal wire is actually copper, stranded copper, probably number 16, maybe 14. And then, of course, the feeders are aluminum. So I'll use plenty of Penetrox because I like to. I know I don't have to. I like to do that. I think it's good for the conductor. And some utility companies actually demand that you use them on service equipment, and this is service equipment. Not this particular utility company. This is PSE&G country here. But JCP&L has it in their literature that if you use aluminum conductors, they want you to use the antioxidant on all their connections. Yeah, I keep thinking it. Every time I come here, I'm thinking it. So this is like a week later after that last half of the video here. And this is actually just recently, a couple days ago, from the time that I'm editing this. It's the next night, actually. But I'm going to carry the LB through that orange, the generator conductor there, generator cable, and that's what I did. You'll see what I'm going to do. I'll tuck it into the hole into the house. Okay, and then I'm going to drive a couple of 2-inch screws into the back of that LB to attach it to the house, so that I can grab the generator cable and push it down through the conduit opening before putting the 2-inch PVC sleeve up the cable and attaching it to the house. See, I made the mistake of making that too tight with the screw. I drove it a little too far because then I had to loosen it up to be able to get the PVC into the fitting. But here you go, going through the 2-inch PVC with this cable, a lot easier than 1.25 inches. I understand you can do it with 1.5 inches, but I haven't tried that. But I tried this 2-inch and I thought it was terrific. Just expensive, all the PVC parts. But as you can see here, just play with that cable and eventually it'll get through. And then once it's in there, it's not even under any kind of stress as far as the bending of the cable. I highly recommend, if you haven't tried this cable yet, to buy it. It makes these generator installs very simple, or as simple as they could be. So now that I'm done up there, I'll put the LB cover on, and I think I come back another time to do the caulking. I think I do that later, but I don't know if I include it in the video or not. Make sure that gasket is properly installed behind that LB cover so the water doesn't get in there. Because if water gets in there, it's going to come down. And you'll see, I put the 2-inch into this box, and then I come out of the other side of the box with 1.25 inch flex to the generator. And the reason for the flex is because of the vibration of the generator. I hope you guys are enjoying this video. This generator took about 3 full days from delivery to the transfer switch to the installation to the startup. It really is a big effort to do all the work involved in doing the generators. It starts with ordering the generator and, of course, putting together the permit package. That could be a pain in the neck. You got to do zoning. You got to do fire. Sometimes you got to do building. Obviously, you got to do electrical. So to get all those permits in line, and not to mention zoning. Before I started doing generator, I didn't even know what a zoning permit was, because I'm an electrician. I take out electrical permits. Zoning, what is that? So when you're asked for a zoning permit, you need to get a property survey to submit with the zoning permit application. Now, it might be different where you live. That's how it is here in New Jersey. So you have a property survey done. You submit that, and you mark on the survey itself, on a copy obviously, where you'd like to put the generator. And then here in New Jersey, and in this particular town, we need to be at least 5 feet away from the property line. And then the generator needs to be at a minimum 18 inches away off the house. But on this side of the house, there's not a single window or a single vent or anything. This was like the perfect place. In fact, when you're inside, once we got this generator running, the owner didn't even know it was on because she couldn't hear it. So that's fantastic, if you ask me. But then once the permits are ready, then you can come do the work. And so I got to go back and I got to put in the transfer switch. Then I got to get the wiring in place for the generator and then connect the generator. Usually at that point, we wait for the plumber to get done and we call for inspections. And then once everything's approved, I bring the battery back and I start it up. This one, I got the inspection and the startup on the same day. So that actually just worked out well like that. So that was nice. So with this particular air-cooled generator, what we're looking for as far as the battery is a 26R with a minimum of 525 cranking amps. And that is a Generac requirement. Wiring these compartments here, so I'm connecting the feeders from the transfer switch out to the generator right here. So when the transfer switch calls for power, the generator starts up and feeds electrical power over these lines back to the transfer switch to supply power to the electrical panel. That's what the transfer switch is doing. It's transferring the supply source from utility, which is not working, to the generator. And then it works an opposite way when power is restored. So the transfer switch senses that the power's been restored. It sends a signal back to the generator to say, hey, I got power. We can shut off pretty soon. And the first thing that happens is the transfer happens back to the utility. And then about a minute later, after the generator cools off, it turns off. And then you're just back to utility power. And that's the full cycle of the standby generator. Okay, so these are the transfer switch wiring conductors. This is N1 and N2. That senses the voltage from the utility. And the T1 is the battery charger. Then we have the transfer wires 0, 194, and 23. So that's what I'm terminating right here. So these are spring-loaded connections, which means I'm going to take my flathead screwdriver here and push in on the terminal to open it up. Like a speaker, like an old house speaker. That's how we do it. We're going to push it in, and then we're going to push the conductor in and lock it in place with that spring. It's a nice connection, and definitely you got to take some time to make sure it's done right. If you hurry here and make a bad connection, your generator will not start and definitely will not transfer the load. The internal wiring, as far as the transfer goes, that's a little more complex than I'd like to get into in this video. I know it and I know how to read it, and I have a Generac book. So if you ever have a problem, I was certified by Generac like 10 years ago. So I do have the book and I understand how the transfer works, but I have to refer to it should I need an electrical issue that needs to be resolved. So there you go. So notice the tie wraps in the upper right hand corner there around those signal wires. You want to keep those in place nice and neat. If you like this video, give it a thumbs up, and if you haven't already, please subscribe. At this particular job, I didn't show it in the video, but we also got the oil warmer and we got the battery warmer, which are basically one wraps around the oil filter, providing heat in the cold, and it's connected to N1 and N2, so it's a 240 volt heater. And then there's another mat that sits beneath the battery, the 26R battery, and that keeps the battery warm for when it's extremely cold out, like below zero. I'm using a 26R battery with 525 minimum cranking amps. Actually, that's the requirement. This is a 575 minimum cranking amps battery. And it's real simple to connect. Now let's check her out. I hope you enjoyed this video. It took a few days of making it, mixing it, editing it, uploading it, putting in all of information, calling Generac, get the startup codes, getting the generator here. There's a lot of work that goes into the standby generators. But once you have them, people are delighted. So if you like this video, I hope you hit that like button. If you really like the content, hit the subscribe button. And I'll see you on the next one. Thanks for watching, guys. See you later.